All right, in this video, we're going to talk about distinguishable permutations, okay? We've been talking about permutations, which is placing objects or events or people or whatever the case may be in order, okay? So let's look at words like banana and Mississippi, okay? Can you tell the difference between all the A's in the word banana, okay? And the answer is you can't. All right, if I place this A first in the list and I place this A second in the group or in the arrangement, I can't tell the difference between those two unless I were to, color them red, blue, and yellow over here, something like that, okay? But when I look at this word, I can't distinguish between these A's, I can't distinguish between these N's, all right? So because of that, what I need to do is to divide out the possibilities where that occurs, where the A's are indistinguishable, okay? So to do that, I'm gonna have to use a formula, all right? So the number of distinguishable permutations that can be formed from a collection of n objects, okay, which would be the number of letters in this case, where the first object appears q sub 1 times, the second object appears q sub 2 times, and so on, is the following, okay? So our numerator is gonna be n factorial, just like we did before with our permutations and our combinations. And the denominator is all the letters or objects that we're dealing with here and how many times they appear, okay? So I'm gonna leave that on the screen here as we talk about banana. So how many distinguishable permutations of the letters in the word banana are there? Okay, so first thing we wanna do is we wanna total up the number of letters. And the word banana has 6 total letters, all right? Then I'm gonna go through each letter individually and see how many times it occurs. So the letter B, which we'll call Q sub 1, occurs 1 time. The letter A, we'll just go down the list here. The letter A, which we'll call Q sub 2, occurs 3 times. And N is next. The letter N, which we'll call Q sub 3, occurs twice. Okay, so I've got my 6 letters, 1 and 3 and 2. These values should always add up to N here. So let's plug those into my formula. All right, so 6 factorial divided by 1 factorial times 3 factorial times 2 factorial, all right? So now, you can use the calculator like we have been, but let's go ahead and write this out. So I'm gonna expand 6 factorial to 6 times 5 all the way down to 1, okay? And I'm gonna expand all of these. So 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1, all right? So you can simplify any number of ways that we've learned previously. I'm just gonna go ahead and multiply these out. The numerator is going to be 720, 6 factorial is 720. And the denominator, when I multiply these 3 or these 6 values, I get 12, okay? So let's divide 720 by 12, and I get 60, distinguishable permutation of the letters in the word banana, okay? Let's move on to example 2 here, and let's try Mississippi, okay? Pause the video here, try it out for yourself, and then come back. All right, so Mississippi, let's count all the letters in the word Mississippi, and that's gonna total to 11. And then let's just go down the list here. So M is the first one, it occurs 1 time. I comes next, it occurs 4 times. S is next in line, it occurs 4 times. We get to skip all the way down here to the P here, and P is going to occur twice, all right? So let's plug these into our formula. So I've got 11 factorial divided by 1 factorial times 4 factorial times 4 factorial times 2 factorial. All right, I'm gonna go ahead and write all these out. So 11 factorial, I went ahead and wrote it all the way down. You can simplify it like we did earlier with permutations and combinations if you want. And I did the same thing here in the denominator. I just rewrote all these 4 factorials in the denominator, okay? So numerator, 11 factorial is gonna be 39,916,800. When I multiply all these in the denominator, I get 1,152. And let's go ahead and simplify there. So we get 34,650 different or distinguishable permutations of the letters here in Mississippi. Okay, so that's how we do distinguishable permutations.